Alright, so welcome to lesson 2 of the measurement unit, and we're looking at area. Hopefully by now you've at least done some years worth of area in measurement, whether that's just finding the areas of a rectangle, a square, a circle, and that's it. But we're going to do a couple more shapes. So let's introduce the formulas, and this is something that you definitely need to have in your summary sheet when you're getting ready for the test. So this page here is just the notes section, and this is what you should have open when you're working through the questions. Area is of a two-dimensional shape is the measure of the space enclosed between its boundaries. Basically, it is how much is enclosed inside a shape. So this is a trapezium, and a trapezium is made up of two parallel lines, okay? And then the two outside parts can sort of go in any direction that they want. And the formula is here. So obviously A is at the bottom, B is at the top, and H is the height. The square you should all know by now. It's just length times length. And a square is only a square if it has 4 equal sides and 4 equal angles. The area of a circle is pi times r squared. And we'll go through an example like that. Whereas the radius is the distance from the center outwards. Parallelogram is just two pairs of parallel lines, sort of similar to a rectangle, except the angles aren't all 90 degrees. And the formula for the area is the base times the height. Triangle is, the formula is half of its base, which is the bottom one, times its height. Here is a kite, and a kite has two pairs of the same sides, so the top two are the same, the bottom two are the same. And the x is the width of the kite, and the y is the height of the kite. The formula is half of x times y. A rhombus, similar to a kite, except it has 4 of the same sides, okay? But not all of the angles are exactly the same. Half of x times y. Rectangle, you should all know by now, just length times width. And a sector, now, just like we did in the previous lesson, is the theta, which is the angle inside the slice of pizza that we like to call it, and then over 360 times pi times radius squared, and your radius is whatever your radius is of this sector. Let's just go straight into some examples, work out the area of basic shapes. So every single time you do a question, I want you to do it in 3 steps. Tell me the formula. Formula for a rectangle is length times width. The second step is to fill in the numbers, 7 times 3. And the third step is to actually work it out, but make sure you put it with meters squared or centimeters squared or kilometers squared, whatever it is that your question's asking you. This is a triangle. The formula for a triangle is area equals half times base times height. Area is half times 11, which is the base, times height, which is 5. Your answer should be 27.5 kilometers squared. This is a parallelogram, and the area of a parallelogram is base times height. So that's just, your base is 3 and your height is 1.5. Your answer should be 4.5 centimeters squared. All right, this here is what we call a rhombus. So the area of a rhombus is half times x times y, fill in the numbers, times 9 times 10, and that gets you, you just work that out. That is 45 millimeters squared. This is a trapezium. Now this might be a little bit more tricky, but again, just put in your calculator and you should be fine. This is a calculator test. Area equals half of a plus b in brackets times height. Area equals half. Now what is a and what is b? A and b, doesn't matter which one's top or bottom. 6 plus 4 times the height, which is 3. That should get you an answer of 15 meters squared. Now, here is the area of a circle, which is pi r squared. Area equals pi times 5.1 squared. Don't forget to actually square the 5.1. So when you're putting it into your calculator, I want you to put pi so pi times 5.1 squared. Okay, that's going to get you your answer of 81.71. Don't forget to square it. And then centimeters squared. So they're just a few basic shapes. What about calculating the area of a sector? Now, the formula is here. So all we need to do is just plug it in the formula and get our answer. So how do we work out this one? So the area of this sector is theta over 360 times pi times r squared. So let's just fill in that in. Theta is 260 over 360 times pi times our radius is 24 squared. If you put that into your calculator, you should get an answer of 1,306.90 meters squared. The reason why example 4 is tricky is because you don't really know what the theta is, but whenever we have a semicircle, we know that the theta is 180 degrees. Here also, they've told us the diameter. We want to know what the radius is. So if the diameter is 11, then the radius is going to be 5.5 meters. So it's very important that you put in the right radius value. So let's copy down the formula again, because everything's in threes. Theta over 360 times pi times r squared. Theta is 180 and r is 5.5 squared. That should get you an answer of 47.52 meters squared. Cool. Now, this one, again, slightly trickier. Don't be fooled. Don't think that the theta is 307. We want to know the theta inside the slice of pizza. So if a whole like this all adds up to 360 degrees, then the little part inside here is going to be the missing number that makes it 360. So this here should be 53. And how did I get that? I got that because 360 take away 307 equals 53 degrees. So that's the tricky part of this question, is knowing which theta to use. So then we just go from there. So theta over 360 times 2 times, no, it's not times 2. Make sure you get the formula right, times pi times r squared. Our theta is 53 and our radius is 4. Put that into your calculator, you should get an answer of 7.4 millimeters squared. Last example, last two examples, is to do the same sort of thing we did in the previous lesson, which is the very first thing we did, which was to convert between units of length like this, but this time using the area chart. So let's now go back to where we were. Sorry about the driving you crazy with all the scrolling, but I just thought I'd remind you of what we did at the very start of this topic. And again, this should be in your summary sheet when you make it, because it's just a matter of using the right numbers. So we want to go from meters squared to centimeters squared. Meters squared to centimeters squared means we times by 100 squared. So 7 times 100 squared. And that's going to give me an answer of 70,000. And because it's moved now to centimeters squared, we're going to put centimeters squared. Here, for this one, we are going to go from meters squared to kilometers squared. So we now need to divide by 1,000 squared. 1530 divided by 1,000 squared, which gets me an answer of 0.00153 kilometers squared. And finally, we're going from centimeters squared to kilometers squared. Just like we did in the very first lesson, we just need to do this twice. We need to first go from centimeters to meters, and then we can go to kilometers squared. So 312,100,000 divided by the first one, we want to go to meters squared, so we're going to divide by 100 squared. And that gives you an answer of 31,210 meters squared. Now we need to go one more time and divide by 1,000 squared. So 31,210 divided by 1,000 squared. And that should give me an answer of 0.03121 kilometers squared. Cool. That should relate to question 2, I believe. And last example, example 6. In millimeters squared, the area of a square of length 8 centimeters is what? Here we go. Let's draw that out. Okay, let's draw this. Here's a square. They all have equal angles and equal sides. And the length is 8 centimeters. So the area of a square is length times length, which means the area is 8 times 8. Which means the area is 64 centimeters squared. But we want to know what the area is in millimeters squared. Now that's just an unnecessary curveball, but let's just do it anyway. So we want to convert centimeters squared to millimeters squared. So what do? Centimeters squared to millimeters squared means we go from here to here, which means we need to times by 10 squared. Times by 10 squared, and that's going to get us 6400, so 6,400 millimeters squared. Cool. So hopefully that helps you answer the questions you need to for lesson 2, and the questions you need to do are up at the top of your lesson. Good luck.